The last part tells us, by drawing a sketch of another suitable curve in the same diagram, deduce the number of distinct real roots for the equation x minus 2 over the square root of 4 minus x squared is equal to x minus 1 x plus 2. So if you recall, what I've already drawn is y is equal to x minus 2 over x minus 1 x plus 2, right? So what I'm going to try and do is I'm going to try and see, can I get that expression to appear somewhere out of this equation? And in this case it's quite easy. Here's my x plus 2, there's my x minus 1 times x plus 2. So rearranging, I get x minus 2 over x minus 1 x plus 2 is equal to the square root of 4 minus x squared. So the graph that I need to draw is I need to draw this graph, y equals to this. So what is that graph? Y equals to square root of 4 minus x squared. Why does it look so familiar? Well, because it's the positive y portion of the graph, y squared plus x squared equals to 2 squared. So this is of course a circle with radius 2. So why don't we go back up to our diagram and we'll sketch the top semicircle of this. Why the top? Because I'm only taking the positive square root, I'm not taking the positive and negative square root. So I'm going to take the top half of the semicircle, radius 2, and draw it on this diagram. So where's that going to pass through? Well, its center is 0, 0. It's going to pass through this point 2, 0, and this point, negative 2, 0, and 2, 0. And it'll also pass through this point 0, 2. So when I sketch it, and again, I'm really sorry, it's not that easy. You can see already I haven't set this up exactly ideally, but let's try. And you guys don't do the sketching technique either. This is very, very bad of me. You guys should do better than this, but again, I'm a little bit limited by the technology that I'm using. It does, however, let me erase. So I'll erase and change where 0, 2 is. And this point here, of course, also so I get something that looks like this, right? This is minus 2, 0. And this point here, 0, 2. Right? So how many real roots will this equation have? Well, you can see that it intersects here, here, and here. So this is going to have 3 real and distinct roots.